So continuing on now with the 2022 AMC 10A Problem 8, it was also the 12A Problem 6. A data set consists of 6 not distinct positive integers, 17525 and x. The average arithmetic mean of the 6 numbers equals a value in the data set. What is the sum of all possible values of x? By the way, we're going to talk about sillies in the future, but right here equals a value in the data set. My brain went, don't forget the x. And so if you forgot that, there is a wonderful trap answer waiting for you. We'll discover that in just a moment. Let's get on to what this is. If I want the average of 6 things, you want to add them up and divide by 6. So I've got 10, 9 and 1 is another 10. I've got 20 plus x over 6 needs to equal, and you're just going to find a way to set this up, right? So you know that you're multiplying by 6 each time. So for instance, let's say I set it equal to 1. Then you're going to have the calculation 20 plus x equals 6. This is a test as well. The algorithmic process by which you solve can pay huge dividends on your time savings. So right here at this point, when I was doing the problems on my own, I immediately just started multiplying all the values. I went 1, 7, 5, 2, x, and I'm going to multiply all of them by 6. So I'm going to put equals 42 equals 30 equals 12 equals 6x. Then over here now, I'm going to get x equals negative 14. Here, I'm going to move the 20 over and get x equals 22. Here, I'm going to move the 20 over and get x equals 10. Here, I'm going to move it over and get x equals negative 8. The last one we'll do separate. 20 plus x equals 6x. Move the x, get 5x, get x is 4. Now, what did it say? Go back and check. This is the point you want to go and check what's there. So it consists of 6 not distinct, that's fine, there's a couple 5s, positive integers. Okay, then if x is negative, does that work? No, it does not. I am curious to see if that's also a trap answer. We'll look for it in a second. But first, let's get the actual answer. You're going to get 22 and 10 and 4. If you forgot to set it equal to x and then multiply by 6 and all that, if you forgot that, you would have got 32. Waiting right there, pretty good trap answer for you. Now, what if we had taken these two negative 8s and wiped out the 22 and forgot the negative 14 and negative 8 to wipe this out, and you forgot this 4, there would be a 10 here for you as well. I don't know how you would get the 26, maybe if you only got the 22 and the 4, but you forgot the 10. I guess that might be it. Anyhow, the answer is 36. Be really careful about trap answers as you're going through. They are trying to trick you. Remember that, right? That's the goal, and you're trying to avoid it. Experience teaches you how to avoid mistakes. That's why a lot of people say, solve thousands of problems. Let's get on to the next one of those. Okay, so continuing now, we have the 2022 AMC 10A Problem 9. It's also the 12A Problem 7. A rectangle is partitioned into 5 regions as shown. Each region is to be painted a solid color, red, orange, yellow, blue, or green, henceforth known as A, B, C, D, and E, so that regions that touch are painted different colors, and colors can be used more than once. How many different colorings are possible? You have kind of 2 approaches here. One, you could do casework. So for casework, it would be something like these 2 could be the same or different, these 2 could be the same or different, and these 2 could be the same or different. And you could do all of the cases where like these 2 are the same and these 2 are the same. That'd be like one case. So for example, you might go A, B, B, and then C, and then A. Something like this, and you could say this is like case 1. And then case 2 would be that you keep the A's the same, but these no longer are different, or no longer are the same. So you would put like A down here, and then in the middle you'd have a D. So you've got these 2 the same. Then you do another one with these 2 the same. Case 3. And you could say, for instance, if I put the A there and the A up there, and then B, and then C, and then D. And so first you have this pair the same, then you have this pair the same, then you have them both the same. Another case could be where these two are the same. So if we said C, B, and then you have A, D, and A. So now you have those two the same. And finally, case 5, all different. Basically, each one of the boxes is a different color, and you would have 5 factorial ways of doing that. So after you make the cases, it's actually not that hard this way, but it's not quite the most efficient way. We'll get to that in a moment. The next thing that you could do here then is say, okay, how many choices do I have for A? I've got 5 choices, B 4 choices, C 3 choices. So 5 times 4 times 3. On this one, it's 5 times 4 times 3 times 2, which is equivalent to 5 factorial. 5, 4, 3, 2, 5 factorial. 5, 4, 3, 2, 5 factorial. So you would then have 4 times 5 factorial plus 60, 20 times 3, and 5 factorial being 120. 4 times 120 is 480 plus 60, 540. Okay, as mentioned, casework was not required. There is going to be another opportunity you could have had at the beginning if you spotted it, and if you didn't, it's okay. Okay, when I show you the solutions, I'm generally showing you what I did to solve the problem. Even I don't always find the most efficient way. And that's just, you have to roll with that on the task. Just like any sports team doesn't always get maximum efficiency when every play that they run. Neither will you. So I'm going to give you the faster way now. This piece is kind of chairman of the board. And so you could say that you have 5 choices for this one. Once that piece is chosen, this piece must be different from that one. So I have 4 choices for that one. This one has to be different from both of those. So it has 3 choices. Now this one only has to be different from these 2. So it would again have 3 choices because you can reuse colors. And finally down here it has to be different from these 2. It could be the same as either one of those, which is why you would again have 3 choices. If you then multiply 5 times 4 times 27, 20 times 27, 540. Pretty slick if you thought of doing it that way, but we're going to get on to the next problem. So for the 2022 AMC 12A problem 8, the infinite product, the cube root of 10 times the cube root of the cube root of 10 times yada yada yada, evaluates to a real number. What is that number? You should know that the 8th root of the bth root of C is A times B. You can multiply those and make the indexes multiplied. And in turn, this could become C to the 1 over AB. And that's what you're going to do here. This is going to be 10 to the 1/3. And then times, this is now the 9th root of 10, because you just multiply those. And so you're going to get 10 to the 1/9, and then times 10 to the 1 over 27. And when you multiply numbers with the same base, we add their exponents. So you're going to have 10 to the power of 1/3 plus 1/9 plus 1 over 27. What is this? It's infinite geo. Infinite geo has a formula, a sub 1 over 1 minus r. That should be memorized. You got to know that. So what is it? Our first term is 1/3. Our common ratio is what you multiply. That's what the r is. I multiply 1/3 by what? 1/3. And then times 1/3. And then times 1/3. And over again. So it's going to be 1 minus 1/3. That's 2/3. That's 1/3. In ratio, it is 1/2. And you have a 10 as your base. So 10 to the 1/2. Radical 10. Let's get problem 9. So for this problem, the 10A problem 12, the 12A problem 9, man, lots of words. So we'll go through it. Don't got a lot of board space, but we do what we do. On Halloween, 31 children walked into the principal's office asking for candy. They can be classified into 3 types. Some always lie, some always tell the truth, and some alternately lie and tell the truth. the alternates arbitrarily choose their first response, either a lie or the truth, but each subsequent statement has the opposite truth value from its predecessor. The principal asks everyone the same 3 questions in this order. Are you a truth teller? The principal gave a piece of candy to each of the 22 children who answered yes. Are you an alternator? I'll just erase this now. I know I'm going to, and change it to what it's supposed to be, which is 15. The principal gave a piece of candy to each of the 15 children who answered yes. Are you a liar? The principal gave a piece of candy to each of the 9 children who answered yes. How many pieces of candy did the principal give to the children who always tell the truth? So let's think about these. First off, are you a truth teller? The truth tellers are going to say yes. So we're going to call them T, and we're going to add, and for A, the alternators, I'm going to have X say yes on the first answer, and then A minus X say no on the first answer, okay? So then, are you a truth teller? The liars, of course, going to say yes. They lie constantly. So this is T plus L plus the X that say yes from the alternators group. Now keep in mind the alternators that are saying yes are lying. We'll get to more of that in a second. This is equal to 22. Now, are you an alternator? Okay, so first, of course, they're going to say yes, we charge car batteries. All right, anyways, so what are we going to do here? Alternator. The truth tellers are not going to say yes to being an alternator, right? The truth tellers will say no. The liars will say yes. And all of the alternators who had previously lied, that X value, they're now going to say the truth. So they're the same people who are now going to tell the truth, because here they're lying and here it's the truth. Right? And so then this is going to equal 15, and we're basically done. You can take this and subtract that, and you get that the truth tellers is 7. But just to check real quick, are you a liar? The truth tellers aren't going to say yes. They're not going to get candy there. Now think who will say yes. The liars will not say yes. Only alternators who had previously told the truth will now lie and say they are a liar. It's the same people who were right here, and so this will be 9. And it's only alternators who say yes to this question, okay? So the answer is going to be 7A. There is one thing you could do if you didn't feel comfortable in here while you're making this and you wanted to be careful. Let's do yes versus no. And we're going to have the question 1, question 2, question 3. So we said that X say yes, and they are lying here. And then that means how many say no? A minus X say no, but they're telling the truth. Okay? Then in a second, they're asked if they're alternators. And since the liars just lied, they're now going to say yes again. Previously it was a lie when they said yes. Now they're telling the truth when they say yes. So this is going to be X, but it's the truth. And again, A minus X, they had just told the truth. They're going to lie and say, no, not us, we're not. So they lie. Okay? Then in question 3, they're asked if they are a liar. Notice it does not say, are you lying? That's different. That would be weird and probably create a bunch of issues. So are you a liar is a type, one of the 3 types. Okay? So I might have thrown a few of you off. I know it made me think a little bit. I had to think about, was I actually asking that? And so there, are you a liar? The truth tellers of the alternator group are now going to lie and say, yes, we are liars. So they are the same ones that say yes every time. And these ones, they're not liars. So they're going to tell the truth and say, no, they are not liars, but it's the truth this time. So that will help you then process how this works. You can go ahead and plug in the numbers and solve for the whole thing. We don't actually really care that there's 31. You can go back and make sure that it's consistent with that if you would like. For instance, since t is 7, x is 9, L is 6, x 9, t 7. If you add this up, it's 13 plus, or 15 plus 7, 22, as we know. Then how many people are there? There's 9 people in the alternator group that said no. So in fact, the same number of alternators are saying yes as well as saying no each time. So that's kind of interesting too, but you can go back and check to verify it works. We're done with this one, and we're going to start the next one. Okay, now we're going to do the AMC 10A problem 14 and the last problem of the set for 12A, problem number 10. How many ways are there to split the integers 1 through 14 into 7 pairs so that in each pair the greater number is at least 2 times the lesser number? So a little bit hard to tell kind of how we would approach this. I would probably start thinking about 14. 14 could be paired with anything from 7 to 1. But 13, because it's only twice 6.5, could only go from 6 to 1. 12 could also go 6 to 1. And now you're kind of getting a flow going. You're just going to kind of fly through now. 11 is 5 to 1. 10 is 5 to 1. 9 would be 4.5, so 4 to 1. 8 would be also 4 to 1. Now, when we get to 7, let's start thinking about some logic now. These are the 7 largest numbers. They're all going to have to be paired with the 7 smallest numbers, right? Because why? If I tried to pair 8 with something that was not one of these smaller numbers, I would have to have another number that was at least double it, like 16, and that's not available. So none of these can pair with each other, and as a result, these are the only options. Now, this is the most restrictive. You wouldn't want to start up here because this one's going to be more restrictive for you. So I think 14 actually would have to go with 7 now that I think about it, because what else would 7 go with? Again, if I tried to pair 7 with something smaller like 3 to 1, think about the numbers from 8 to 14, there's 6, and from 1 to 7, there's 6. By pairing 7 with the 3 to 1, you take away 2 of these, and now there's only 4. All 6 of these cannot pair with 4 of those, which means one of them has to pair with something in this group. And that's not possible, so we know that 7's going to have to go not here, but it's going to have to go with the only one it can go with, 14. So 14's going to go with 7. But after we've made that choice, I think it's probably, what I did is I went down here and I said 8's going to have 4 choices, right? Something from the 1 to 4 range. It will have 4 choices, and then the 9's going to have only 3 choices because the 8 took one of 9's options. So it'll be 4 times 3. Times, when you go up to the choice for 10, you gain access to 5, but keep in mind 2 of the numbers from 1 to 4 are gone. So you take 4 minus 2, but you gain 1. Now you have 3 choices again. Okay, so there is 4 choices here, and then 3 choices, and then 3 choices. When you go here, this is the same group this one has, but it now has access to 1 less because you've used 3 of those numbers in these 3 picks. So you're going to have 2 choices here. Same thing, I'm going to see how it's status quo, 3, 3. This will go 2 and 2. Why? Because you've used 4 numbers from the pool of 1 to 6 already. And there's 2 numbers remaining from the pool of 1 to 6. And you get to choose one of those 2 to go here. You have a choice between 2 things, whatever they are. And this one's going to have 1 way left that it can be paired with, whatever's left at that point. So we got 4 times 9 times 4. And so you're going to get 16 times 9, 144e. You might have thought there might be some other ways, but you've already got the max amount, and so even if there were, that would be impossible because, yeah, there's nothing higher on the answer key list. We already kind of logically established that there's no other way to go about it. Let's get on to the next one.